Welcome to part 6 of our Competency 17 practice. In this video, we will use the TI-84 to find the area under the normal curve given one or more z-scores. Quick note before we begin about normal distribution in this area of stats. If you're not familiar about some of these topics in a more in-depth essence, I suggest that you go to the internet and view videos, do a quick refresher. In my videos, we just don't have time to hit those areas because we are focusing primarily on the TI-84. Number 1. Use the image above to order the normal distributions according to their standard deviation size from greatest to least. This isn't meant to be a difficult question, just to measure what your knowledge is, if you have any idea what it is. So let's look at the green colored curve 1. If you look at it, it thins up. And that deviation, well, I thought I changed that color. Okay. And you see how it thins up. Now just use that idea to look at how the curves flatten or narrow. So the narrowest deviation, standard deviation, would be the green. And then the next one would be our red. Actually, no, the blue. The red would be the largest. So see how it flattens out? And if you look at that, see if you measure against the green, looks like you can get an idea from over here that maybe that's one standard. You'd have to compare them against z-scores. Either way, you can kind of just tell by eyeballing, and they just want, I think that's the purpose of this question, is to test that. And we see that that's D. It would be 1, the green, then 3, the blue, and then 2, the red, is the most narrow. I'll erase all my mess there so you can actually look at it on your own. Maybe stop the video and look at it. And it wouldn't hurt to look at other questions similar to this. Okay, let's go to number 2. What is the area to the left of z equals 2? Well, there's z equals 2. Let's highlight in what they mean. Not to the right, to the left. That's important. Looks like we want all of this. I'll have to make mine. Okay. All of this. Let's see what that looks like on the calculator. So we need second vars. Now, that is actually number 2 on our list. You can arrow down or push to, it doesn't matter. It's easy to see where that is. And enter. Okay. If you don't remember or you're not familiar with this, where the cursor on the calculator is flashing, that is your lower end of your distribution. It is pre-calculated into your calculator, which I've always liked that. That would be saying that, okay, here's your low end. Now your 2's your upper end. So that's convenient. And we can just say enter, put 2. Notice it's a positive 2. And our mean or mu is still going to be 0 because we're talking about the normal distribution. And we still have a standard deviation of 1 because it's normal. Enter, enter. And that is correct. Now, there's 2 ways you may see this written. Okay, so this is almost equal to 0.9772, or we can say 97.72%. Okay, number 3. What is the area to the right of z equals 0.8? Okay, let's change up colors. Okay, so we want to estimate about where that is. Okay, we're going to draw a line all the way down where 0.8 would be. Make sure you go back, double check your number. Well, even if you're not going to sit and draw it in. They may give you drawings where you have to choose the options, but I'm drawing it just for visual's sake. So we need to go to the right again. Now. Prior problems to the left, now we're going to the right. Okay, so we are filling in this entire piece. See if I could draw a better line. We're going to go all the way down. It's somewhere in there is where we want to begin. The difference is, okay, we're going to go number 2. We can't use the pre-entered value. So how do we deal with that? Do we know what the upper value is? Actually, we do. It's just the positive of the pre-entered lower. So let's clear that out. Okay, we need 0.8. We've got our 0.8. That's our lower end of measure. Enter. Our upper end is the positive. This is the quick way to enter it. 1 second. We want our E value. Now push 9. Enter, enter, enter again, and enter. It's a lot of entering, I know. And that gives us an actual pretty accurate answer. So that's almost equal to 2, 1, 1, 8. Actually, that will round. Let me just rewrite that. That is not okay. I didn't do any of that correctly. Okay, we are almost equal to 0.211 rounded to 9. Remember in stats, that's where we round to the 4th decimal, which is almost equal to 21.19. 19%, 20%, or you might have a case where they just simply rounded it 21%. Number 4, what is the area between z equals negative 1.5 and z equals 1.5? Okay, what we need to do first is draw that zone. So this is just about negative 1.5 and then negative 0.5. That's our zone. I'll highlight that. We need the zone in between those values. Just a quick sketch as a visual, so you have an idea of what we're doing. All right. Let's put that in the calculator. So we need second vars 2. Our lower bound is negative 1.5. The upper bound is negative 0.5. And we enter. And yes, that gets us roughly 0.2417, which can also be written as 24.17%. Okay, number 6. What is the area of region that lies within 1 standard deviation of the mean? Okay. They are talking about from negative 1 to 1. So that is from here to here. Okay. All right, so let's see what we have here. Second, vars, and 2. Our lower bound now is -1. The upper bound is simply 1. And we enter until, yes, that is about 68.27%. Now, this is a common number that you may be asked again, but it doesn't matter about trying to memorize it. This gives you a way, instead of memorizing, to actually just come up with it on your own. I've made that mistake in the past, so I'm just telling you from experience. You will be asked questions about this, and if you don't remember, it's okay. What you need to remember is how to use your calculator to come up with these things. Okay, while we're here, let's talk about the area under the curve from, let's say, -2 to 2. You don't have to push all those buttons again. You go up, highlight your CDF. Oh, sorry. Oh, well, I say that. Okay. Just enter once. Okay. Now we arrow over. And what I'm trying to point out is the first two elements, that's your lower and upper bound. So we want a lower of 2, arrow over, upper of 2, and that gives us that estimate percentage. So we have 95. Be nice if I could write. Okay, let's see here. 95.45% rounded. Okay, and you could find the other sections as you're asked, as you need to know. Okay. Number 7. What is the area of the regions that are greater than 2.5 and, oh, that should not say greater. Right. Good thing. That's a typo. Less than z equals -1.2. So let's put that in first. 1.2, that'll be somewhere in here. And then 2.5, 2.5, that's somewhere in here. Well, I'm looking at this blue area and this area in here. Those are the areas that we want. There's just a problem though. Our normal CDF will not give us these values. But if we think about this, under the curve, one of its properties is that it equals 1. Well, how about simply subtracting this area? If we put the upper and lower bounds of our z values in, but subtract that from 1, we will get the blue shaded area, which is what we want. Okay, so what are we going to do? 1 minus second vars 2. Our lower bound is -1.2, and our upper bound is 2.5. Let's see what value we have. Yes, that is correct. And notice how it is a smaller percentage or a smaller value. So that is almost equal to 0.1213. Okay. I know this was a short section, but thank you for watching. We will continue with the properties and calculations for normal, standard distributions and other aspects related to that in a few more videos. Thank you.